Alrighty. So I'm going to assume most of you know the OpenLDAP project, yes? All right. Founded in 1998, so we're actually celebrating our 20th anniversary this summer, August. Right now there are 3 core team members that are steering the project, and there's a random number of contributors. We haven't been releasing quite as often as we used to, but yeah, still around every couple of 12 or 18 months. And my company, Simus Corporation, founded in 1999. So we've been doing this for 19 years. My partners always ask me to point out that we are a self-funded company, no venture capitalists involved. I'm one of the founders and currently the CTO of Simus Corporation. I've been writing free software since before free software was a phrase, like in the mid-1980s. I've worked on all the GNU tools. I've worked on a bunch of different developer projects, build tools. I worked at NASA for 3 years on the space shuttle. I have software in orbit around the Earth. Hasn't crashed yet. Okay, so topics for today. Recent OpenLDAP 2.4 releases, features we're talking about in 2.5, and other things that are underway, work in progress. We've been trying really hard to wind down the 2.4 release stream. 2.4 was first launched in 2007, and we haven't been able to kill it yet. But it is, okay, I already have to lie here, because we've already said it was feature frozen, but a couple of people on the list have begged for 2 or 3 minor new features to be added. So in 2.4.47, that will be a minor new feature release. Things in backsock and a couple other things. But aside from that, it is absolutely for sure frozen. Yeah, so 2.4 is winding down slowly. Things we've added in 2.5. These are features that have actually been in 2.5 for a couple of years now, and they've matured pretty well. So one of these multiple thread pool queues allows us to scale much better on many core servers. And we've got some rework in the connection manager, doing write wait handling. We've also got new support for these offline tools, slap modify and slap delete. So that complements our slap add and slap cat. And one of the big features we added was support for LDAP transactions in all of the primary database backends. So the thing about multiple thread pool queues, in all the releases up to 2.4, there's a single thread pool that allocates worker threads to every operation. It turns out that this is a single queue with a single lock, and that gets bogged down pretty heavily under large workloads, heavy workloads, and it doesn't scale well on multi-core servers, right? It turns out that any single mutex is really only good inside a single CPU socket. Once you have to cross a CPU socket boundary, the bus contention really kills you. So what we do now is we have you can configure any number of queues, and ideally you do 1 queue per CPU in the machine. All right. So this has had a huge benefit for our throughput. You can see in the 2.4 server where we're doing 32,000 searches per second with a single queue, we can now get around 37,000 searches per second on the same machine with no other tuning changed. We've also tested this on much larger machines. Oracle invited us down to their headquarters in Dublin last year to test on this experimental hardware, Oracle M8, with 2,000 CPUs and 1.5 terabytes of RAM, running pre-release of Solaris, you can see that before tuning we were peaking at 180,000 searches per second. After we configured more thread queues and a couple more worker threads, we were hitting 930,000 searches per second on that same box with nothing else changed. So this feature itself is a huge deal if you're running on a multi-core server. And at this point, I'm always happy about this. The profiling of this workload showed that there was no longer any bottleneck in the OpenLDAP code. The bottleneck was inside the Solaris kernel. In general, when you're configuring these things, you probably want no more than 16 threads per queue. That was the sweet spot we found. Okay, so in releases up to 2.4, there's a single thread that's responsible for selecting on all socket descriptors, right? So it selects for read and it selects for write. Now, normally we don't care so much about writes, but it turns out that if you have slow clients or a slow network, slapd writers can get blocked waiting for the clients to read responses. Okay, and again, we see this under very high throughput workloads. So in 2.5 now, instead of making the central thread handle write waiters, we actually move that into each worker thread. So worker threads don't take quite as much overhead, and the central thread can focus all of its attention on readable sockets. And the main impact from this is if you do have some slow clients that are causing the write queues to back up. You know, if everybody's fast, you probably won't see any impact from this feature. Okay, so slap modify and slap delete, these are just offline command line tools. The main reason we really need these now is so that you can edit the cn equals config database while slapd is shut off. But I mean, obviously you can use these with any other database too. So the LDAP transactions RFC has been around also for several years now. Support is complete now in the three primary databases, back-mdb, HDB, and MDB. We're looking at adding it to back-LDAP, but it turns out that that really shows a gap in the transaction spec. You know, the transaction spec really needs to support two-phase commit if we're going to do transactions distributed across multiple servers. So we're working on that. So those are features that have been in the source tree now for at least a year. These other features I'm talking about here are slightly newer. In syncREPL, okay, currently the syncREPL consumer does a full transactional write for every incoming modification. All right, it turns out it's actually doing 2 or 3 writes because it writes the modified entry and then it writes a new context CSN for every modification. With lazy commit now, we basically say we're doing asynchronous writes into the underlying database, so we don't have to wait quite as much for each one, and then you can do a periodic sync. So this helps in a couple of cases where the replication consumer is a little bit slower than the provider. In this case, with the lazy commit, the consumer has an easier time keeping up with the incoming replication. For a very long time now, we've had start TLS and SASL interactive bind in liblldap, but both of those were only synchronous functions, right? You had to sit there and wait for them to complete. We've actually added non-blocking asynchronous functions to liblldap for that now. So if you're using liblldap in some other external event loop, this will make your life a little easier. We've added support for SASL channel binding. So this basically allows you to pin the security of a TLS session to the LDAP protocol session, right? This is a feature that SASL added in the past couple of years. And it only recently got supported in GNU TLS and OpenSSL. So we've added those hooks into liblldap. One of the bigger things in crypto recently is elliptic curve cryptography. All right. With elliptic curve, you can use a 256-bit key that has the same security as a 4096-bit RSA key. All right. So ECC is kind of a cool thing because it's more compact, it's a little faster to verify. So we've enabled support for that as well. If you guys are using FreeBSD or macOS, see on Linux we've had support for epoll and these other faster select mechanisms for quite a long time. We had an experimental support for BSD-KQ for several years. It didn't quite work. So one of the FreeBSD guys has been pitching in to polish that up. So that's in better shape now. Other new features. There's a new database backend called Wired Tiger. It was the Wired Tiger guys were some of the refugees from Sleepy Cat, Sleepy Cat, who wrote Berkeley DB. So instead of a very sleepy cat, you now have a very wired tiger. So that backend was contributed by open source group in Japan. There's a new backend called asyncmeta. So it's like back-meta, but it runs completely asynchronously. Every operation that goes into the meta backend just runs into its own thread pool, talking to whoever the remote servers are. And again, the main reason for this is if the remote servers are running a little bit slower than slapd, this way it doesn't tie up all the slapd worker threads. Right. So that's new in 2.5. We have a new, it's kind of a standalone server called LLoad. It's a load balancer. So this would replace like an F5 hardware load balancer, right? It's completely software driven. It's being merged into the slapd code base now. So it was a standalone server. Now it's just going to run inside slapd. Lots of new modules. If you're into two-factor authentication, TOTP is something you probably use quite often. So there's a TOTP password module in the new source tree. There's a bunch of new extended operations. There's a couple of overlays here like AD remap and USN that support Microsoft schemas. There's the auto CA overlay, which is an automatic certificate generator. I'm pretty happy about that one. So the auto CA, as soon as you start up slapd with it configured, it will look to see if there's a server certificate configured and a CA certificate. If there's not, it'll generate one. And so it'll generate the CA, and it'll generate the server certificate based on the base DN of the server, okay? And then any user who comes along and does an LDAP search for their own DN, their own user certificate, if it doesn't exist, it'll get generated on the fly. And obviously, the DN in the certificate will be the DN of the LDAP user, right? So you can not only automate distribution of personal certificates to all of your LDAP users, you can actually automate for all of your services too. Okay. On some larger databases, okay, currently indexing in slapd is based on a 32-bit hash of any value, all right? Turns out in larger databases, we're starting to see index collisions, right? So new in 2.5, we have 64-bit indexing. That helps quite a bit to avoid false index collisions. We've had this separate LDIF parser library that was called liblldif. A lot of distros tended not to package this because they didn't know it existed or something. So we've actually just moved all of that inside liblldap. Just makes application writing a little easier. there's now in cnconfig there's a disable flag for databases and overlays. So this was kind of a temporary move before we had delete support, right? So you could configure a database and decide, oh, maybe you don't want to use that one. You could temporarily turn it off. In the syslog output, we now have high-resolution timestamps. We used to only have timestamps down to 1 second. Now we log down to the microsecond. And the log actually shows two values. It shows how much time an operation spent in the front-end queue waiting to be executed, as well as how much time it spent being executed. With part of the work with the auto CA overlay, we now can store TLS certificates and keys directly as attribute values of cn equals config. Whereas before, you configured the path name of a file that held these things. Now you can store the actual certificate and key just inside the directory. In back-mdb, just like in BerkeleyDB, we used to store entries as a single blob. All right, so no matter how many attributes or values or whatever, it was stored as a single database object. Turns out in back-mdb that can be a little bit inefficient as entry sizes go up. So now we have an option where you can store multivalued attributes as individual database blobs. All right, and this helps in a couple of things. If you have, for example, we had a customer with a group with 2 million values in the member attribute, all right? And every time they inserted or deleted a member, this thing was, well, it was slow. So now, since each value is its own database element, inserts and deletes are very fast. Okay. Some things that we're still working on. Faster logging mechanism for slapd. This turns out, logging still turns out to be a heavy bottleneck for us. We are looking at two-phase commit for LDAP transactions and also in LMDB. And LMDB itself is undergoing a few enhancements. If you look at code in glibc for syslog, you'll see this is some of the worst code I've ever read. It requires a mutex to write on a datagram socket. Now, datagram sockets are inherently atomic sockets. Anything you write on them is guaranteed no conflicts, no intermixing. So this whole mutexing around it is an utter waste. And the impact of syslog, really kills our performance. If we're running 200,000 queries a second with logging turned off, as soon as we turn stats log on, we drop down to 21,000. So we're paying a huge price for using syslog. Previously, I worked on a streamlined version of syslog, took out all these unnecessary mutexes. That only got us to 26,000 queries a second. So we're now looking for a binary log format. And the scheme that I'm looking at right now is simply to write our stats messages as, okay, let me walk you through this. The first idea was we'll write stats logs simply as the BER LDAP packets. We'll just write them to a binary file. But it's like, oh, but if I do that, then I still got to write a log processor tool that makes it human readable. How about if we write them out as PCAP format, and then you just run Wireshark if you want to read the log. All right, so that's probably the scheme we're going to go with, because that means I have less code to write. And, efficient code is, and if efficient execution is about code that didn't need to get run. Efficient programming is about code that didn't need to get written. We tried exploring all these syslog alternatives, and they're just not fast enough. So binary format seems to be the way to go, and it's probably going to be Wireshark compatible. Two-phase commit for LMDB. We're probably going to have to extend RFC 5805. This really is the only way to go if we're going to support transactions through back-LDAP and back-meta. Okay, there's a bunch of other new features in LMDB 1.0. All of these exist in separate feature branches right now, so the work at the moment is simply to merge them all back into the master branch, which is taking a little longer than I thought, but there you go. It is. Any questions?
Okay, when is 2.5 come out? Because there's a few features there that would benefit me at the moment, because I've got two groups that are both with over 200,000 members in them.
Oh, right.
I'm mitigating around it a little bit by using valve sort and things like that, but I still see the CPUs, spike when there are somebody comes in and out of those groups. And the syslog is also a bit of a bottleneck that I see, because at the moment it's going through system D and syslog, so we're basically doing the same job twice so we can then external logging.
Okay, so like the large attribute value stuff, that's already in Git master, and we're looking at a 2.5.0, pre-alpha in a couple of months from now.
Just very quickly, what was the motivation? Did you guys write LMDB?
Yes.
And what was the motivation for it?
Well, okay, so I started writing LMDB back in 2011. We actually wanted something better than BerkeleyDB since, I'd talked about it since 2009 at least, all right? If you look at what a traditional database does, like BerkeleyDB, it's spending 25% of its time managing user buffer caches, 25% of its time managing locks, and 25% of its time managing a redo log, the transaction log. All right, so it only spends 20% of actual CPU time doing the work you asked it to do. Okay, so in LMDB, there's no transaction log, there's no fine-grained locking, and there's no user-level buffer cache. All right, so basically you get 99% of the CPU doing exactly what you asked it to do.